Hey everyone, welcome to The Explainer. Today we are mapping out humanity's cosmic future. We're going to start by scanning our own celestial backyard for potential threats, then look at the very real active steps we're taking to defend our planet, and finally, we'll check out the massive hardware powering our next giant leap into deep space. Let's just dive right in. All right, let's kick things off with a massive number, 40,000. That is roughly the number of near-Earth asteroids that scientists are currently tracking. I mean, space is vast, sure, but having 40,000 massive rocks flying through our local neighborhood, that definitely demands our attention, especially since that number is growing literally every single day as our detection methods get better. So, that brings us to a pretty provocative question, right? With tens of thousands of space rocks just zipping around out there, how is humanity actually preparing for the future? Well, the good news is, we aren't just crossing our fingers and hoping for the best. We are actively identifying these threats, engineering real defenses, and building the technology we need to eventually leave the nest.
Okay, part 1, the asteroid threat, keeping watch on the solar system.
Now, according to researcher Nikolai Zheleznov from the Institute of Applied Astronomy, scientists have discovered over 1 million asteroids in our solar system. Sounds terrifying, but the vast majority of those are safely hanging out in the main belt between Mars and Jupiter. However, about 4%, which makes up those 40,000 near-Earth asteroids we just talked about, have orbits that actually bring them right into our direct neighborhood. But here is where the story gets really interesting. Zheleznov points out that out of that huge pool of 40,000 near-Earth objects, currently only 154 are strictly classified as potentially hazardous. To earn that scary title, an asteroid has to be over a kilometer wide, which is, capable of global devastation, and have an orbit within 7.5 million kilometers of Earth. So the threat pool shrinks significantly, but those 154, they demand absolutely constant surveillance. So, who exactly is watching the skies for us? Well, one key player is the Quasar-KVO Radio Observatory Network, operated by the Institute of Applied Astronomy. And rather than just one giant telescope, this is a massively spread-out network of radio interferometry observatories spanning across Russia. We're talking from the Svetlay Observatory in the Leningrad region down to Zelenchukskaya and all the way east to Batary in Buryatia. Networking all these widespread sites together creates this incredible, ultra-precise net for tracking really fast-moving celestial bodies. Moving right along to part 2, planetary defense in action, from observation to intervention. So, what do we actually do about these rocks? Well, our proactive defense timeline is already well underway. Think back to September 2022, when NASA, quite literally and intentionally, crashed its DART spacecraft into the Didymos asteroid pair. It was a massive test of the kinetic impact technique, basically seeing if we could physically punch an asteroid off its trajectory. And now, the European Space Agency is stepping up, launching their Hera mission in October 2024. That spacecraft is set to arrive at Didymos by December 2026 to measure the exact aftermath of that impact. And pulling off a mission like that requires some seriously impressive engineering. Just think about the central core of the Hera spacecraft taking shape in a Swiss cleanroom. Built by teams from RUAG Space and OHB, this entire structure is made of carbon fiber reinforced polymer. It's this incredibly stiff, super high-strength cylinder that essentially serves as the fundamental backbone of the entire spacecraft, safely supporting all those vital deep space instruments. Once Hera finally arrives at its destination, it conducts what the ESA playfully describes as a cosmic crime scene investigation. First, it navigates to the Didymos pair out in deep space. Then it performs this super close-up mapping of the exact crater left behind by NASA's DART impact. Finally, it assesses the asteroid's internal makeup and structure, because, if we ever actually need to deflect an Earthbound asteroid for real, we absolutely have to know exactly how different types of space rocks absorb a massive kinetic punch. All right, that brings us to part 3, powering deep space exploration, leaving the nest. Now, protecting our planet is crucial, obviously, but what about leaving it to explore even further? Well, traveling deeper into the cosmos requires a ridiculous amount of power, and that exact power is currently being tested at NASA's Stennis Space Center. NASA administrators Bill Nelson and Pam Milroy actually toured the facility recently. They've got this colossal B-2 test stand out there, operating day and night. Fun fact, this is the exact same stand that successfully handled 1.6 million pounds of thrust when they were testing the first core stage of the Space Launch System. That is just mind-blowing power. And the testing there almost never stops. We're talking massive, 500-second, full-duration hot-fire tests of RS-25 engines on their Fred Haise test stand. Over 8 straight minutes of literal rocket fire. And they aren't just dusting off old heritage engines either. They are testing brand new development models packed with components made using straight-up sci-fi techniques, like 3D printing, selective laser melting, and hot isostatic pressure bonding. The whole point is to make the engines of tomorrow faster to build, way cheaper, and much more reliable. Standing in front of that kind of raw power really puts the current momentum of our space program into perspective. As NASA Administrator Bill Nelson put it so perfectly during his visit, come February, engines like this are going to roar to life, and we're going back to the moon. You can absolutely feel the excitement, right? The era of humanity just hanging around in low Earth orbit is officially coming to a close. All of this incredible hardware feeds directly into the Artemis era. Those RS-25 engines are going to drive the Space Launch System, which is specifically designed to carry astronauts, including the very first woman and the first person of color, right back to the lunar surface. But here's the kicker. The moon is really just a proving ground for us. We are learning how to live and work on another world so we can prep for the ultimate objective, a human mission to Mars. So let's look at the big picture. From global observatories keeping a watchful eye on 40,000 near-Earth rocks, to carbon fiber sentinels like Hera advancing our planetary defense, all the way to the deafening roar of RS-25 engines prepping us for Mars, humanity is systematically securing and expanding its cosmic future. As we continue mapping these threats and building the incredible engines of tomorrow, what do you think humanity's next great leap in space should be? Keep looking up, folks, and thanks so much for exploring with me today.